So just one more second to gather all our guests inside, and then we should start. Good. So good afternoon to all of you, and if it is not too late, very happy New Year. My name is Simone Tagliapietra. I'm a research fellow here at Bruegel, and I am really pleased to welcome you at our house for what promises to be an exciting event about one of the major trends that are certainly reshaping our energy systems, digitalization. Digital technologies are indeed set to transform the European energy system, ideally making it more connected, reliable, and sustainable. The electricity sector, and in particular smart grids, are at the center of this transformation, but certainly we can expect all the sectors of both energy supply and demand to be involved by this transformation. Just think about the rise of connected devices at home rather than the rise of new mobility solutions, all of them enabled by digitalization. Digitalization is also key, and that's also why we are looking at that with that much interest. It's a key to foster decarbonization, making it easier to integrate variable solar and wind supplies into the grid, into the system. So, in a nutshell, many are the opportunities that we see in digital energy, but of course there are also several challenges that need to be addressed, such as security, of course, and privacy issues. Our conversation today has a triple aim. First of all, we want to better understand, and that's mainly with the help of Laura, the changing landscape. So how really the system is going to afford this digitalization. But then, and that's why we have two companies here with us, we want to understand the implication of this transformation for the energy system, for the energy industry. And then, and that's why we also have the European Commission that is just arriving with Mark, we will also explore the policy implications of this change. So, without further ado, I would then immediately like to introduce you our distinguished speakers. Laura Cozzi, first of all, head of the Energy Demand Division at the International Energy Agency in Paris. Hans Niemann, Senior Vice President for Energy Products at Prysmian Group. Jean-Jacques Marché, the Director of Energy Efficiency at Schneider Electric, and just arrived with us, hello, Mark von Stiput, the Deputy Head of New Energy Technologies at DG Energy European Commission. Laura, I would immediately give you the floor for your kick-off presentation. Thank you.
So thank you very much, Simone, and thanks a lot to Bruegel for having organized this meeting. I was here already couple of months ago on a completely different topic on energy in Africa, and I can tell you that the room here is really 10 times more people, so it's already an indication that how topical this issue is. So the reason why Simone invited us again is, as you mentioned, at the International Energy Agency, we did a first study that looked at the interaction between the energy sector and digitalization opportunity. To our knowledge, is the first of such exercise in terms of mapping in the first comprehensive way this landscape. So what we've been trying to do is basically understanding three things. First of all, how much energy is the digital industry needing today and in the future? This is the first question that we were trying to answer. The second question is how digital technologies that are so pervasive are changing the way different sectors use energy. So ourselves at home, transport and industries, and how is it going to change the outlook going forward? And the third is a much more fundamental question, which is digitalization going to transform the energy business as we know it today? And what would be the key elements for that to happen? So this is a very, the very first thing that one needs to understand. What has happened over the past few years in terms of how pervasive digitalization has happened is astounding. So just to give you one example, this is one of the many indicators you could use. This is internet data traffic from 1987, where if you don't have very good glasses, you cannot even see the small dot there. And the amount of data in 2017 was a number that required a new name to be introduced. It's zettabytes, which means a number with 21 zeros after that. The interesting thing here is not only how huge this is how quickly this is doubling in the very recent years. So we have had a doubling of internet traffic just over the past 2 years. So this is on a very steep exponential trend. And it's not only internet traffic, is everywhere. So the first thing that we try to understand is how much data how much energy is needed by digital companies today. And what we find is that already today, around 3% of electricity use is being used because of storing and transmitting data that we are using today. This may not seem a huge number, but for digital companies and telecommunication companies, this is becoming such an important item in their costs that one of the most amazing advances that we're seeing in energy efficiency are actually happening in those companies. I want to mention only one. This is Google, that for the first time has tried to use artificial intelligence to look at how positioning their servers are actually one of their main users of energy. The fact that they heat up and there are super large areas where those computers are put, they heat up and they use even more energy for cooling and just for making sure that the data are stored and data are transmitted. So the use of artificial intelligence that was done for the first time last year allowed to cut energy use in one of their most efficient data centers in the world by 40%. 40% in one of the most efficient places in the world already for this. So this is an application where we haven't started looking at artificial intelligence in energy efficiency. It could change very much the things in the outlook going forward for energy demand. Staying in the use of energy within the digital sector, we have kept this very short term up to 2020 because it's very difficult to understand what will happen beyond 2020. The amount of data that is going to be used is going to increase very, very fast. But what we've been seeing so far is that not only because of artificial intelligence, but simply for energy efficiency reasons, we are expecting this to remain flat. This doesn't mean that there is no reason to worry, but that there are a lot of advances happening on the efficiency side of the story that are keeping this flat. One thing that is happening, which is quite interesting, is that there is an increasing blur between the distinction of digital companies and energy companies. Why is that happening? Digital companies are worried about the energy aspect of it. So they're becoming increasingly interested in procuring energy. And so they were one of the main drivers in buying renewables. So they are really becoming a key leading role in energy, in actually building and securing new energy, and in energy efficiency, in innovative energy efficiency solutions. And they are acting as new actors in the energy sector. Thanks to the digital technologies, we'll come to this later, we are seeing new actors appearing in the energy sector. The opposite is true as well. If you look at the investments by energy companies across all energy types, from utilities to transmission to oil and gas, the fastest growing segment in investment is related to digital. So there is an increasing marriage happening between those two large sectors. If you go quickly and look at very quickly, and you can find all the information, in fact, since it's a digital report on our website on www.energy/digital, you'll find all of the report in digital form, actually, meaning that it's not just the PDF of this report. It's a bit more advanced in terms of data downloading, etc. Building sector. Smart thermostats. Double-digit growth over the past 2 years in a number of regions, including the US, including Europe. What are smart thermostats doing? They are allowing us to consume energy better. Our first assessment is the following. There is a potential for the smart thermostats to be very widespread, and those are matching better our energy needs and actually the supply of energy to our homes. Without including connectivity here. So here we are really talking about, I'm putting a smart thermostat that in a way is not very intelligent, that is just doing a better profile of my demands and learns what time I'm coming back home. We finished this, now you're going back to your office, but maybe you know that at 6 o'clock you're going back home. At 5 o'clock you're going to use one of the apps on your smartphone, and your heating is starting, so you don't have to heat earlier. By when you arrive at 6, your house is going to be at 21 degrees. There are energy bills that are attached to this type of solutions, and energy savings that are attached to the solutions. Are they huge? Not so much. We estimate around 10%. But those can be quite significant because you cut demand in certain areas of certain moments of the day. And this applies on 2 main energy carriers. Is natural gas, because in heating is where we see most of the changes, and the second one is electricity. So an improvement, not really a big game changer, we would say. On transport, this is probably the area that is being most discussed about. We're seeing digitalization being more and more used on road freight, and I'm here with my colleague Timur Gul, who led an analysis on trucks, and in that analysis, what he and the team found was that through digitalization, platooning, and a number of optimization that digitalization allows, you can get savings of around energy of around 20 to 25%. This is starting to be a bit more significant. On road passenger, we are talking about automation, electricity, and digitalization. This is an area where much more work needs to be done. Preliminary analysis shows that energy demand trends could go in all directions. You could actually cut energy use of cars compared to today by half, or you could double it. And this very much depends on one thing. If I suddenly can get a car that comes here, I don't need to drive it, and I use the time to go to this place, to the next, to work, the value of that time can be very important for me. So actually, we could increase our demand of travel a lot. And this increase of travel could actually offset all of the saving that could be achieved through having a more intelligent system, a system that is all electric, and it's a system that is shared. So sharing and the value of the time will very much determine what is the future of the demand into this segment. This is an area where we are starting to do much more work because, again, the team are working on that with other colleagues, because it's fundamental. What policymakers will do in this segment is going to be key and can really have a very different outlook for oil on one hand and on electricity on the other. On industry, a lot of talk about digitalization in industry. What we are seeing is that energy at plant level is digitalization at plant level through optimization, predictive maintenance is actually making the plants work better and work longer. In some cases, this is locking in assets that are not tremendously efficient, so it's not necessarily always a very good news. But it's inducing cost savings. So we're seeing a significant take-up. Where we see the largest potential advances are in 3 areas. Sorry, this has gone too far. Is it 3 areas? 3D printing, artificial intelligence, and robotics. Those three areas could really change the link between energy use, productivity, and output, and could significantly change the equation. This is just one example of using 3D printing in the aircraft industry, and what you see is two quite significant changes in terms of energy demand outlook that doesn't grow at all, and at the same time, material demand is completely different. So there are potentially disruptive technologies that could alter the outlook in very specific industries. Similar story is true for the oil and gas sector. Digitalization in oil and gas is actually opening up more resources in the long term, around 10%. It's also true for the power sector assets, where we're seeing savings of around 80 billion a year because of digitalization. This is quite significant, especially in utilities in Europe, where electricity demand is not growing very much and is really doing the make or break of certain utilities. How quickly you make the investment in digital to remain in the market and in business with revenues. So if we were to conclude here, probably you would conclude that, okay, digitalization is bringing a way of efficiency throughout different sectors, but there is no equivalent of Airbnb, of what Airbnb has done to the hotel industry in the energy sector. Well, it's not true. We actually think that is in the connectivity and the systemic changes that digitalization could really break and transform the energy sector as we know it today. Let me give you one example and we go into a bit of the details. Up to now, especially on electricity, what has happened is that you had the power plant, very clear operator, producing electricity and unidirectionally selling it to a buyer. So you have a buyer, you have a seller, and you have a transmission network. What digitalization is doing through connectivity is actually allowing multi-directional flows. So we ourselves at home are completely changing our roles. So if you go back to the equivalent of Airbnb, Airbnb made us all know that we may have had a spare room that had no value, and suddenly I put it in a market and I have a value for that. What digitalization is unveiling is that actually we do have, for energy, the equivalent of some capacity at home that we can sell back to the grid to get value out of it. So this is doing two things. First of all, I was passive before, I'm becoming active. It's completely changing my role, and it's completely changing the role of the other actors as well. And the other thing that it's doing is actually unlocking idle capacity and services in places where they are there, but we're not using them. So very quickly, four major opportunities that we see emerging out there. The first one has to do with demand-side responses, so with really all of us. With an estimated potential of 1 billion households being able to participate in demand response markets with over 11 billion smart appliances. What does it do to the system? It means that I would have built some capacity of CCGT or new plant that I don't need anymore because I can actually meet demand and supply better just using our flexibility at home, moving by a couple of hours my load, by moving by 5 minutes, moving by 1 minute my load. In terms of money, if that talks better, we are talking something close to 300 billion. This is not necessarily peanuts. So this is the first major transformation. Second, electric vehicles. Why is electric vehicle important? Is again a new area that can not only use electricity, but I can act as a balancing item for the grid once again. Here what we see as being key is making sure that the investments that will happen in charging and infrastructure are smart and not dumb. We can come back to that later. Obviously, integration of variable renewables, I think I don't need to say much here. What digitalization can do and enable in terms of avoiding curtailment is huge. For Europe, we have done the analysis, you can cut it by nearly 90%, is a huge number. And finally, it has to do with us and with distributed energy resources and with the name that is is very much a la mode today. So blockchain technologies, you can really see eventually, and it's not going to be everywhere, and all of us are going to become prosumers, but this is opening up something that was unthinkable just a few years back, a completely new role of houses that are self-sufficient and can do transactions among this building and the next in a very secure way. So, very couple of concluding thoughts. The energy system is on the cusp of a digitalization year. Is this just evolutionary or revolutionary? We think this is going to be more of a revolution type of thing. This is clearly a first-of-a-kind report, so it has opened up a lot of new doors, but it has all its limitations. We want to do more work and understand better certain things. A lot of uncertainty, not only on the technology part of it, but it's a lot about behavior. How are we going to react to autonomous car? Are we all ready to go and jump into it? So the way the human being will react to that, are we going to be happy to use artificial intelligence everywhere? How are we going to react to data protection and data privacy? Are going to be all very key questions to understand how quickly this can all happen. In terms of ourselves, we identify cybersecurity in the energy sector as one of the key areas, as well as data privacy. And what we want to work more now are three topics. As I said, road transport, automated, connected, and electric ACEs, so vehicles. Smart energy system and smart grids, so integration of renewables and demand-side response. And digitalization and decarbonization, really the question, is it so obvious that if we digitalize more, we can decarbonize faster, or there are trade-offs and things that we need to look at a bit more carefully? Thank you.
Laura, thank you very much for this kickoff presentation, because it really allowed us to have a complete overview of the landscape that we are discussing, the challenges and the opportunities. I think that many inputs that you gave will be then discussed during our discussion later on. But now I would really like to give the floor to Hans for his remarks, because Prysmian is being a producer of both electricity and telecommunication cables, is in a very peculiar position at the crossroads of ICT on the one hand and energy on the other. So we would be very much interested in understanding how you see energy digitalization from your perspective.
Thank you very much, Simona. You touched on a number of topics that I would also like to touch on, but then from a perspective of the products that we are producing in this sense. Simona said Prysmian Group. I think there is Prysmian Group is the global market leader in the production and installation of optical fiber, telecommunication cables, and energy cables. Energy from cables in this building to cables in mines, cranes, but certainly also the large high voltage connections that connect countries and islands and cities to the grid. I think one of our main developments that we are going to see in the next 10 years is the twin relationship, and Paula has already touched on it, between decarbonization and digitalization. I was a couple of weeks ago, just to make the topic very, very concrete, a couple of weeks ago I was in the south of Germany talking to one operations manager of a small Stadtwerke, of a small local grid that was serving a number of villages in the South German area. And the gentleman explained to me the enormous difference that he has gone through in the management of his grid in the last couple of years. Was it a monodirectional, very clear feeding in of the grid through one of the German nuclear plants in the south, the man is now faced with an enormous amount of volatility in his grid because of solar parks that are connected to it, because of wind farms that are connected to it. So the way he was describing the potential hotspots and hotspots in a grid is potential failures that he will have in the grid are really enormous. And he needs a very active management of the grid in order to prevent that the lights goes out when they do not need to go out. So the man was screaming for information that would help him to manage the grid in a proper way. And that is central to the product development that a company like the Prysmian Group, but also many other companies that are working in the energy environment. This is pivotal to what we are going through in the next 10 years. From very passive components, cables, you put them in the ground, they are there, they will stay there for mostly many years. From passive components, a development to active components in the grid that can provide information and that will help the grid owners to be able to assume the renewable power that is going to be generated. Let's not forget, currently only 5% of the daily energy supply in Europe is coming from renewable sources. If this is going to increase in the next 10 years exponentially, what everybody is expecting that is going to happen, the impact on the grid is only starting. It's only the beginning, what we are seeing of something that if we do not make the grid more intelligent, we are going to prevent actually the growth of decarbonized assets into the grid. What we want to do, and these are, and this is an example of product thinking that is going on into our group, is making cables intelligent means you are entering sensors into cables, you are acquiring data, you store them in a cloud platform, you put a number of learning mechanisms on it in order to be able to predict in the end what is going to happen inside the grid. So it is a step that many are undertaking, and it is bringing innovation to the management of energy assets that is going on in the next years. I would like to give you just one example, and maybe later on I can give you other examples on what is happening here. But very interesting that Paolo said also that energy and telecommunications are intertwining. We are developing hybrid cables currently that is a combination of energy and all sorts of optical elements inside the cable, where we would be able to measure temperature, which is extremely important if you operate an energy system. You can measure temperature. You can measure sound that is going to happen. You could see this cable as a sort of a distributed sensor. You can measure sound, and that is going to be extremely important in a number of applications. Take, for example, an undersea cable between, between Italy and Greece, or between Scotland and Norway. I think it's not only Russian submarines that may touch on those cables, as we have recently heard, but it's much more anchors of ships, fishing equipment that is trawling the sea bottom, that is going to touch those type of cables, both optical and energy cables. And nowadays, these cables are laid on the bottom of the sea, and they are passive. You lay them there, sometimes you bury them if they are not deep enough, but they are there, and you do not know anything about it, except for the fact that once it goes wrong, it goes seriously wrong, and it takes you a very long time to repair those type of cables. So the possibility to sense, catch information, store information, not only about temperature, because you can see temperature rising if, for example, a cable is going to be unburied, because you can sense those temperature differences inside the cable core. But you can also hear ships approaching the cable. Not only submarines, but certainly fishing vessels, anchors that are being dragged on the ground. So it may give you sometimes time to react, but certainly it gives you an immediate indication that something is happening to your cable. And the necessity to do this type of things, the necessity to make cables intelligent, is a necessity to be able to quickly decarbonize this world. So what I'm saying is that from a perspective of a manufacturer in the energy and telecom grids, these are extremely exciting times. When I joined many years ago the industry, and I told this also to Simone, people were raising the eyebrow because this is a very conservative industry that doesn't change, nothing is happening, dominated by engineers that their only task is to keep everything as it was. It's no longer the case. This is as Paula also said, this is an industry in motion, and it's going to revolutionize, and products will revolutionize. Customers will change very quickly. Googles are entering the energy area, and the Eons are entering the telecom area. So there is a lot of change going on the customer base also that will drive, again, us to develop new products and new services. It's not only the hardware, but with data, as everybody knows, you can also offer a lot of services to your customers, which has value for them in the management of their grids. So digitalization is an enormous necessity to create decarbonization, and decarbonization is a growing impact and a strongly growing impact on all the grids that are in the European area. So I would leave it with that, and maybe we can talk later on some more examples that I can give there. Thank you.
Thank you very much, Hans. And I will now turn to Jean-Jacques, since you manufacture energy management and automation solutions, and you find yourself by definition at the forefront of digitalization of energy. How do you see these trends going?
Well, thank you very much, Simone, and thank you very much for the invitation. Good afternoon, everybody. I'll try in the next 12 minutes to do three things. First, the implication we are seeing due to energy digitization. How do we see the implication? The second one is to illustrate it with concrete examples. And the third, will be how we think that policy and regulation can be accelerator in the move we are in. So digitization, I would say, for us is really a key enabler of the transition we are making to the new energy landscape. The new landscape we are already building, we have started to build, and we think there are three things which are first the decarbonization. And that is, in fact, one key objective with, and we should not forget, I'm using a diagram which I love from the International Energy Agency, where it's very clear that decarbonization will be a success with two things: energy efficiency, and that is something critical, and development of renewables. An integration of these renewables in our energy system. In fact, the second is decentralization, and we believe that this is a paradigm shift. And in fact, in a way, we were used, and Laura has been illustrating it quite significantly, quite well. We were used to a central system feeding, consumers. Now we need to reverse, and we need to change the paradigm and start with the demand, working on the demand, and integrating a complete different attitude. Energy consumers are becoming active. We can call them prosumer because they can generate locally. They can store. They can adapt their demand response, manage their flexibility. And this, of course, is one key success of the transition and of this new world we are building. Just up of these prosumers, because centralized system will stay for a certain time, and we need, in fact, to manage the coexistence of both decentralized and centralized, which means for the distribution grid a real big evolution. And in fact, we have spoken about a double flow of energy, of information. It means really far more flexibility, so automation to get this flexibility, and new design and operation to integrate renewables. And of course, the digitization finally is really this enabler to do that, due to the more real time it can allow, due to integration it can permit, and we need to think about this digitization over the full life cycle. The digitization for sure brings benefits all along the chain, and I think that, Laura gave us a figures of $80 billion, which can be saved yearly with digitization. I've got another figure, and I think it comes from Capgemini, which is, 27% down cost of the energy generation by using digitization. So all along the chain, but I want to focus on, for me, what is the real paradigm change we need at demand side. Indeed, technology costs are decreasing. Generation, look at solar costs. Battery, storage is going to be the same story. Digital costs are decreasing very significantly, communication and so on. The sensors, automation, control, communication can so be developed around the whole system. And if you take, the demand side, if you take the user, I've got really an illustration of something which is already a reality. I'm taking a non-residential building where you can see that we are having, local generation, we're having storage, we're having, loads which are well controlled, including EV charging, and we can manage in an efficient and flexible way this prosumer to optimize the CO2 emissions, to optimize the energy consumption, so the cost, and that is really something which already is a reality. The way we're doing it, and I think, here what I want to insist, it's really an end-to-end architecture which need to be implemented. And in Schneider Electric, what we have developed under the name of EcoStructure is an architecture which start, with the product where we are having, now our product are really IoT enabled. And when I mean the product, it's the circuit breakers, it's the switches, it's all the distributed product in the electrical installation. They have already embedded intelligence to make some local control at the device level. They are then, connected to edge control where we are having local real-time control to provide system safety, efficiency, and flexibility. And then the third layer is, in fact, application, analytics, and services, which can be either in premises or in the cloud. The point, in fact, is that you need really consistency in this architecture, and specifically for things like cybersecurity. The more we are developing definitely IoT, the more we are developing connected products, and the more, this cybersecurity issue is important. Oops. Examples. We have seen, a prosumer at the level of a building. Today, already, we are developing microgrids. And microgrids, in fact, just to make it simple, what I said on the level of a building, you just put it at the level of a district. And you can have something which you can switch on to the grid or switch off to the grid. Again, where, digitization is very helpful is that you need to synchronize generation and loads in the microgrids. You need to synchronize them as well, when connecting to the grid or disconnecting. And you need to optimize and manage the whole of the sources and loads. So these are realities. The next example, and I'm there at distribution level, where really digitization of distribution networks is critical to be successful in the move. And there, what does it mean? To make it simple, it's more real-time automation of distribution grids. That is something which on transmission grid is already existing. In distribution grids, believe me, when you look at them, it's quite poor in terms of automation and control. And in fact, that is really something which is necessary if we want to integrate renewables, which just, keep in mind that more than 90% of the renewables are connected where? At the distribution grid level. It's very necessary in terms of real-time operation. It's really necessary as well in terms of operation where you're not in real time, but you make network analysis and you make, network development planning. You will get the slides available. Don't worry for the details. But I think that is really a revolution in the world of distribution operators. My last slide is to say, well, technology is there. Costs are reducing every day. That's not enough. We need really a framework to accelerate the move. And that framework, policy and regulation can really make it. We need for trust, acceptance, and adoption by stakeholders, which needs a clear, consistent political vision with really showing that we have no choice, we have benefits, and that is really necessary. Cybersecurity and data privacy are key issues. I think that in EU we are at the phase of implementation. We believe that is really key. We know at Schneider Electric we are in critical infrastructure since a long time, and cybersecurity is really something we are mastering. We think that here we need to be very successful in the deployment. We need for common standards and interoperability. And here I think industry has the role to play. Skills and competencies, believe me, that is really a challenge. And when we're speaking about skills and competencies, it's not just IT skills and competencies. The point is to get people from the traditional energy world and people from the IT to build something together. And that is a challenge. And at the end, the last but not the least, strong business cases need to to encourage the development of new actors. We should not put burden with legislation to people who are starting to make aggregation, to people who are starting to make self-consumption. We should, on the opposite, encourage them. So I think that, the discussion which are right now in Europe on the clean energy package for all are good discussion on the market design. What we do hope is that the framework at the end will really be favorable for this development. Thank you.
Thank you very much, Jean-Jacques, and thank you also for the assist you give me in order to give then the ball to Mark to go into really the policy discussion, because what is astonishing here is the speed of this change, and that was clear in all the presentations we had. So the question, of course, is how can policymakers keep up to the speed of this change, and put in place policies that can actually favor this transition and not hamper it. So, Mark, what are you doing on this?
Thank you. No, that's a very easy question to answer. No, of course, this is it's a huge subject, and many compliments to the IEA and to Laura for putting this kind of in such a, let's say, well-organized and covering everything basically linked to digitalization in one report, and then being able to present it in 10 minutes and still make sure that everybody follows you. So that is really very important work also for us. And I hope you will allow me to highlight a few things and focus on a few things, because if I have to talk about everything, I'm going to stick here for a few hours. So I will focus a little bit on things that particularly we're doing in DG Energy, of course in cooperation with others, and focus particularly on the energy systems and how everything is coming together. And of course, when we look at digitalization, we look at it as a enabler for the EU to make the transition of the energy system happen. More concretely, to integrate higher shares of renewables and to improve energy efficiency. So, and of course, keeping our competitiveness, keeping, let's say, affordable prices for consumers, and keeping competitive prices for the industry at the same time. So the digitalization is really a core element to make all these things happen. Maybe I spend a bit of time on what that means for our way of working next to what we're actually doing. Because as you say, and you said it as well, the things are going very, very fast, and much faster than, let's say, 10 years ago or so. So new market models, new business models, experiments are really going very, very fast. I think you mentioned the example of blockchain, which was, at least if I speak for myself, and I hope I don't disqualify myself too much if I say that I really didn't know much about it, or haven't even really heard about it apart from Bitcoin a year ago. And then I remember being in the utility week in Barcelona, where it was really the talk of the town, and everything was about blockchain. And now we have a lot of projects that are actually putting it in place and showing how it works. So it's really, from the idea to how do you actually make it work, goes much faster than things we were used to before. And that means that with legislation, you see it with the clean energy package, we're putting that together in record time, getting the Council and Parliament hopefully to agree in record time, but still it takes a few years to make it happen. And so we have to make sure at the minimum that we don't have any unintended consequences, that we kill initiatives that we would like to see, and at the same time, of course, keep a clear goal on what the aim is of these legislative packages, so that we unite people around an aim and put principles in place that we think accompany achieving that aim, but without going too much into details. And of course, that all sounds very nice in theory, but in practice, you will appreciate that that is extremely complicated, because if we say we stay at principles, we wouldn't be talking about network codes, about how you actually facilitate electricity trade across borders, where we have all seen that if we don't put it down in the details, it will never work. So there is always a balance between those things, and it's sometimes very difficult to find. And I think even on where that ideal balance is, you will not agree always with all the parties. But nevertheless, it's this, I think, this cooperative approach, like we do in the network codes, at least make sure that we have a good, well-informed dialogue with everybody who is involved in these topics to make sure that we avoid unintended consequences. So making sure that the legislation that we put forward, and the more detailed that it is, that we have a strong, let's say, infrastructure to discuss it with stakeholders, I think is very important. And that is not just for a network code. I think that is also, in general, when we talk about what is coming up in terms of policy challenges, what is coming up in terms of key innovations. I see it also from the unit where I am, which is responsible for part of Horizon 2020. We need to talk to many more people than just our, let's say, traditional stakeholders. When we were pushing for solar PV technologies or PV or offshore wind technologies, or wind technologies full stop, 10 years ago, we also needed to, let's say, support those industries in order to be able to gather their views and tell us what they want. Now, it's an established industry. We don't necessarily need to support them that much anymore, but we need to look for the next ones. And we have to, I think, in particular, if we're talking about things like the next framework program, so FP9, or it will probably get a more nicer or imaginative name, like Horizon 2020 is for FP8. But in the framework of the discussions of FP9, also we need to make sure that we have our how do you call these things in these animals that can kind of sense things even without touching them. We have to have those limbs. This is getting very complicated. What I mean is we have to be able to sense what is happening, not just with our traditional stakeholders, but also with the parties that we wouldn't normally talk to. And that involves other established industries, but that also involves startups, wild ideas, basic researchers, and those kind of things. So and I think the current discussions on FP9 as they are going on also we try to build in more flexibility to provide for research that focus much more on what is actually the target or what are we aiming for, and leave more freedom to how to actually find the solutions than to do the traditional way of programming, which is define very precise what the solution is, what we're looking for. I don't think that is completely archaic. We still need those kind of things as well, but we need to complement it with more open, let's say more outgoing, open ideas, and saying this is what we're achieving, who has good ideas, and then we can support them and be more flexible in how we support it. So I think we're this is a continuously learning effort, but I think we're setting up structures, and we're working on ways how to better sense what's going on and how to incorporate that more easily in our research programs, but also in our legislation. So that's just on the way of working. Next to that, of course, what are we actually doing? Of course, I have to mention the clean energy package. You mentioned it as well. There is some stuff being discussed in the Parliament today, which is very important for us. Of course, the focus is very much on the targets, but there are many things also there that look at how is the market going to function in the future, again, with a view on integrating renewables, promoting energy efficiency, keeping the prices affordable or competitive, but making sure that the way the system is managed is progressing and is becoming much more interactive. We're putting a lot of emphasis on the future role of network operators to use all the possibilities that digitalization brings in order to run the system as efficiently as possible. Of course, the focus is very much on the electricity system, but when it comes to rewarding flexibility, not just in the wholesale market, but also in the balancing market, the frequency response market, congestion management, those kind of things, the grid has to become much more interactive. I think you mentioned that already, so not just, let's say, the smart cable itself, but also the way the cable operators talk to the market, make use of the flexibility they have. All those things are needed because we have decentralization going on, but they're also possible because of digitalization. And I think the legislation puts us on the track. It redefines a bit the role, or quite a bit, the role of the network operators in that sense. And of course, we then also need to accompany that and make that happen. And I'm going to make a bit of advertisement for what we do, but it's a good advertisement because it's about money that we want to give away, not about money that we want from you. We are in the Horizon 2020 work program, we have worked a lot with our colleagues in DG Connect to come up with some joint calls that also try to push for these digitalization solutions, show how they work. Take, let's say, the more abstract or the basic technologies that are being developed on the ICT side and see how they can work and be adopted in the energy system. So I hope we achieve what you say is that they jointly work on solutions. The two sectors work on joint solutions. And one of the key things that is open now is how can we manage basically the interaction between the network operators and everything connected to it. What kind of markets can you create? What kind of platforms can you create? What kind of products do they need to buy? And how do you organize such interaction based on platforms or markets where both the TSOs and the DSOs know what's going on, because they're going to talk to the same assets in a consumer house. So you need to have a very good communication between those parties. So we need to test how such markets should work. That is, of course, the bigger question, and we try to we will fund some projects in Horizon 2020 to address that. Of course, the question then is also how do all these parties exchange data, because in the energy system there will always be different parties that will be involved in, let's say, making something happen, in paying for a flexibility service. So the interfaces between the different parties in terms of data management and equipping them also with the tools to be able to handle these large amounts of data, that also we think needs to be supported. And of course there's a very rapid development in big data technologies, but we need to make sure that they are implemented and used in the energy system. So that's kind of the back office from the network, from the energy system point of view. At the same time, when you're looking at the consumers and their point of view, then we need to make it easy that when they have, let's say, moderately smart home, because they have a smart meter and maybe a smart thermostat, and then they buy an electric car, that those things are able to communicate with each other smoothly, and that they don't need to bring in an installer that has to check whether the washing machine actually can understand what the smart meter says, and all those kind of things, because then all the gains that they may have from making it smart are already gone from the, let's say, after they've paid the bill of that installer. So making it easy on that side, making in particular, the language within which all these things communicate is very important, and this links very much with the bigger work or the bigger developments that we see in the Internet of Things. So that is not just maybe an energy question, it's also a health question, it's also a mobility concept question. And these kind of changes to business models, and in particular the way digitalization allows or will maybe force through a different way of how the energy system communicates with the consumers or customers, I think that is really the biggest change that is coming with this digitalization. I think what you were describing about the cables, about all these technologies, we need to work on those things as well. And there are many things, if you look at, for example, electronics, where the developments are very rapid. I was talking to a colleague the other day who is working on quantum technologies, and who was saying this has really a lot of applications in the energy sector. So there's really let's say a basic technology issue where there's a lot of links between what happens in the digital area and the energy area. But the real changes in the way the energy system as we know it works will come from this interface with the consumer. That will be a big opportunity for European companies if we get our act together, and if we make sure that we create the trust, if we make sure that things are interoperable at the interfaces, if we make sure that platforms can be used in a way that actually facilitates things for consumers, but we are not necessarily leading on those things. There are other big companies in other big competitive economies that are traditionally much stronger. So we really need to catch up, and that is why we also need, in terms of defining the interoperability and the open interfaces, a very kind of cooperative effort. And that is also what we're aiming for with, for example, this IoT call that we launched, to facilitate the competition for having the best and the most intelligent services to the consumers. Very briefly.
Thank you, Mark. Thank you very much. And before opening the floor to questions from the audience and answers from the speakers, I would also like to point out the fact that a few months ago, with Georg and other colleagues here at Bruegel, we published a blueprint on the future of the European industry, to court. We particularly also looked into the future of the energy industry. We looked at how electricity utilities in Europe and oil and gas companies are responding to these trends that are coming up between decarbonization policies on the one hand and digitalization on the other. And while looking at, for example, the case of utilities, we saw a very fragmented landscape, because in Europe today we certainly have some companies like, for example, me, I am Italian, so Enel is clearly in Italy a front runner at the European level in terms of getting into innovative business, getting into mobility and so on. You have Iberdrola in Spain that is doing exactly something of that kind, but you also see some other realities that are far more conservative. So this adaptation to the change is not to be taken for granted. So I wonder really which kind of policy signals we would need to give to the companies to move forward in this direction, also vis-a-vis what's happening beyond Europe and what's also potentially emerging from new players. Because if you have the Tesla of the situation that comes and provides you a package of service encompassing the electricity generation on your from your solar panel on the top of your roof, and then the battery, and then the car, that could actually represent a disruptive trend for established players and open up the opportunity to new players to come into the game. So this question would really go maybe to Laura. If you had a review of what's happening around, not only in Europe, to a little bit understand how the business models are of established players adapting to these digitalization trends.
So maybe two anecdotes from two events. So we had back in November the IEA ministerial meeting, where we had 35 CEOs from all the energy companies in the world meeting, and on the other side, energy ministers from most European countries, but also from the US, Canada, India, China, etc. And energy and digitalization was one of the topics that was addressed in the joint session. And maybe two things out of that session that marked me. First of all, it was very clear that companies were ahead of policymakers. So this is very clearly an area where technology is well beyond policy. And you have two types of actors out there. One that is saying to policymakers, stay completely out of it because we can go very fast without any intervention. And others that are actually asking a regulatory framework to make sure that things move in the right direction, because digitalization is not per se an objective. You have other policy objectives, and you want to use digitalization in the best way possible. This is one thing. So the first race is really between companies and policies, where I think that the companies are ahead of policies in most cases. It's not always true, but it's in most cases. The second is another challenge that I think Jean-Jacques touched upon a bit. It's skills. And skills is a skill set. So a couple of CEOs mentioned that they did internal mapping of within the company who is actually the best equipped with the knowledge of digital technologies and the actual ranking of the people in the company. And you have, not surprisingly, a completely inverse correlation. So you have the youngest generation that doesn't have power, that knows all about digital, and who has power that doesn't know anything about digital, but knows that the most of the gains in the future will come from that. So there is really skills, but is a very complex skills issue that has come about as a very important one.
On this, otherwise I would open the floor for questions. So please, we have already first 2 questions here and then 1 there. So if you can identify yourself, and thanks.
Yeah, so thank you very much. My name is Giorgio. I'm with the European Energy Exchange, the leading energy exchange in the European Union. Thanks very much for all the presentations. It's really fascinating. I would have, let's say, many questions, but because of the business I actually represent, I will only have 2. 1 for the panel and 1 for the European Commission to actually mark. The general one is, I've seen in the IEA report, we also contributed to that digitalization goes hand in hand with decentralization. Mm-hmm. That has an impact as to how you actually trade energy, but in particular electricity. So a question would be, in general, what role would you see for the energy exchanges, meaning the markets, so the energy markets, in an energy world which is increasingly digitalized and decentralized? So that's the first question. The second question for the European Commission is, I understand the support you give into research and innovation as to digital energy and energy in digital. However, are we ever going to see a digital energy legislation in the European Union? And is it going to be driven by DG Energy or DG Connect? It's not it doesn't want to be a political question. It's just to understand what is the angle that the European Commission is going to take. Thanks.
Georg Zachmann from Bruegel. I have a question to Hans and Jean-Jacques. You described the old energy world when beginning with 60-year-old transformers and power lines and power plants. Houses also tend to become quite old. Now, my question to you would be: now, if all this will now take time to replace infrastructure. In terms of timing, is there something where we should act relatively quickly to make sure that new installations are digitally enabled? So is there something where we really need to pay attention that we don't continue to build up stupid cables or stupid houses, or can we re-equip everything and we kind of just wait and see and until we have more visibility?
My question is to IET. In your last slide, you said about the future dimensions of your research, the link between decarbonization and digitalization. This is a very important subject, 2 different kinds of power games going on. But my question to you is, what kind of methodology do you have in view? Because as you know, CO2 and the other greenhouse gases have no common methodology of assessment or retrieving. So everybody decides what he wants. And that is why these COP have not progressed. But on the other hand, digitalization, as you have very well shown, is more precise. And there are different kinds of energy economies at stake, and therefore different effects on climate. So my question to you is, how do you go to treat that very tricky issue?
So maybe, Laura, we might start with you on the exchange first and then on this methodology issue.
So very briefly on that, I think that in a way the answer has already been given. We don't think that we are going to jump to blockchain everywhere tomorrow. and that there is going to be quite some time in which you will see a coexistence of more traditional energy markets and exchanges and more decentralized solutions. So the tricky part is going to be in the hands of policy making. How do we make this system, these mixed systems, work for a very long period? Very long, we don't know how long it's going to be, but sometime there is going to be this coexistence. On decarbonization and digitalization, there are many interactions, but there is one among the several that we started looking in a bit of a quantitative way that was, I wouldn't say that was worrying us, but a bit put an alarm bell. In many ways, digitalization is helping decarbonization because you can integrate better variable renewables. You can delay or avoid the construction of power plants that you would have otherwise needed to build. However, in some cases, I mentioned this earlier, the asset lifetime is changing, and is changing for longer periods. So we would have older capital stock of inefficient or necessarily not the most desirable forms of generation that would stay around for longer than we would have anticipated. So this would be the area where we want to look a bit in more details. So if you're going to extend lifetime of very inefficient coal-fired power plants for 5-10 years, this is not necessarily what we would have expected. It's for Europe, where there are already certain designs in place. We may already see how the solution is there, but there are other economies for which it's not so obvious. So this is one of the key issues.
Right, Mark, on the Derby DG Energy, DG Connect.
On the next digital energy package, yes. Of course, I will go to say that we should settle and implement first what is now on the table, which has a lot of digital elements in it. Sometimes very explicit in terms of smart grids, in terms of smart buildings indicators, energy communities, which is also something that is only possible because we have digital solutions there. And it's difficult to say what the next Commission is going to think of all this. But in general, I would think that, let's say, when it comes to this interface between the consumer or the customer or the citizen and the energy system, I am not sure whether we need to do things specifically for energy, because this interface, let's say from our logic, okay, our DG or many of the people here probably, that you would think, okay, we want them to do things from an energy point of view, so we have to maybe legislate and push for it. But from a consumer point of view, he will say, okay, I'm going to renovate my house, let's do something smart. What do we have? Okay, it can be for security, for health, because I'm getting old and I would like to make sure that I can stay in my house for a bit longer. I don't know what kind of things, but I think that what we should make sure is that whenever such things happen or whenever business models come up, that it's very easy to also link that with energy solutions that are good for the energy system. And I think this setting a trajectory that we start rewarding consumers for doing things that are good for the energy system and for our energy transition, that is what is being put in place now with the clean energy package. Of course, it will not be perfect, so there will be follow-up codes, whatever, further discussions. But we have to also approach it much more from the consumer point of view, or from the citizen point of view. What is he looking for, and how can we create businesses that offer them solutions that they like? And so there we need to have a much more integrated approach, in particular if you talk about services and platforms and those kind of things, than energy only.
Hans, there was a question on the infrastructure.
The thing that we can do immediately, in my opinion, is to make sure that we we include the electronics into the components that we are installing now in order to be able to use them for the future. Is not the interaction that you need tomorrow, but the possibility to use components like cables in the future as active, intelligent components of a network. This is what you can do now, and in my opinion, that puts also some more focus to the DSOs instead of the TSOs, because if we talk about grid development and the investments in the grid, we always think a lot about TSO developments, but as Jean-Jacques was also saying, the real revolution is going to take place within the DSO systems, in the power distribution systems. And luckily enough, the utilities that operate in this area, within any framework that we can set up, in the end, a utility is a listed company with shareholders. So when it is investing, it should be investing profitably for its shareholders. And what we are currently seeing, and that is at least a positive sign that could, I think, influence in a positive way the investments that you are doing in smart grids, is that the allowed return that the DSOs are getting on their regulated asset base is positive. Is a higher allowed return than the weighted average cost of capital that they are having. So there is every fundamental incentive in place for them to invest. Because if they invest smartly, they will get a return which is higher than the cost they have put in. So we need to put in the electronic components now in order to benefit for the future. I think the DSOs are important to look at, and I think there are fundamentals in place that will make this smart grid possible.
Well, I mean, there are two questions, I think. For me, the first one was digitized and decentralized. What does that mean in terms of exchanges and rules of exchanges? I think, I mean, there are immediate things which we need to put in place. For instance, dynamic tariffs. I mean, we really need to have at retail tariffs which vary according to the time, and even, why not, the location where you're using, I mean, electricity. And that is for sure not just to give the wholesale and access to the wholesale variability for the end user. Because when you take the retail, you've got 1/3 energy, 1/3 network charges, and 1/3 taxes, and so on. So we should go a bit further and think about network. What about paying as you use? And having, I mean, something which is dynamic as well, according to the time you use the network. It's for sure as well that, you know, we were in a kind of product out system, and we were paying the number of kilowatt hour, which were falling down when we were tapping the switch. We should really make a move to a market in. And in fact, I think that the flexibility should really be rewarded according to the benefits it is giving. I have in mind a study by the MIT, and they took, and that was with dynamic tariff, with flexibility market, and they took a non-residential building, I think it was an office building, and they made a simulation on what would be the cost of electricity according to what you draw from the grid and what you give in terms of flexibility. And guess what? 0. The client was able to offset the cost of electricity was drawing by the flexibility he was selling. So I think that we will see a lot of changes in here. We were discussing about communities, aggregation of users at a community level where you're having, I mean, pattern of consumption which are different is a gold mine. So we need, I mean, these are the type of things. Really, we're speaking about peer-to-peer. Believe me, collective self-consumption will come and will have a lot of sense. So that's just to illustrate. I mean, of course, I mean, what speed, how much it will develop. I think regulation has got a big role to play in that. It's no more an issue of technology, believe me. Now the second question was the speed, in a way, I mean. And of course, we've got, I mean, existing infrastructures which still we can make money out. And they are definitely accelerators or brake about the move. I'm taking it in a perspective which is carbon budget. Do we have the choice? When we're saying, for instance, and it's in discussion, the target of renewable for 2030, don't know, 27, 30, 35, 40, anyhow. What is sure for me is that in 2030 in Europe, we need more than 50% of the electricity generated from renewables. And believe me, the major part of that will be decentralized. So if we think in terms of carbon budget, really, that is what should draw, I mean, the movement. Of course, are we ready to put the necessary carbon price? That is another, I mean, issue, which is just to show that the move, in fact, we are really having decarbonization, decentralization, and digitization connected. I believe that we have as well, I mean, the electrification, and we need really, speaking about a carbon budget and carbon success, we need really to have more electrification of end uses. We are discussing about transport, heating is another one. And that's how things will be driven. Of course, again, I think that policies, regulation have a very strong role to play. I think that, I mean, what Laura was discussing about, I mean, these energy ministerial meetings, I think these type of things are very important. The finance world and the industry world as well has changed. Believe me, if you look at what happened during the last 3 years, for me, I mean, it's fascinating. I mean, this issue, starting with the energy efficiency 10 years ago, and even a bit more, and for me, I mean, the biggest movement I saw was during the last 3 years, the movement from the financial institutions and from the industry. Look, the US. Of course, we've got, I mean, the policy, I mean, at the US, at the global country level. But if you go in states, you've got different policies. If you look at cities, if you look at industries, they are fast movers. And that's for me, I mean, I'm just trying to illustrate the different drivers of the move.
Thank you very much, Jean-Jacques. We would have a question on the second row here. Thanks.
Thank you. My name is Peter Bocek. I'm with the European chemical industry. And we are a large energy consumer and also a solution provider in terms of energy efficiency, greenhouse gas efficiency, as you will know. When I hear the buzzword decentralization, it reminds me of a fact that it's not new. We have had decentralized energy generation for centuries. I remember the thousands of windmills that were in operation in the Netherlands to pump the water away from the land and also to mill the wheat. So why have we moved away from that? Not because there were engineers that were sticking to old stories, but because there was innovation and there was also more efficiency in centralizing things. And that is also a thought that I have, well, are we now inviting each and every household and each and every garage owner to install a windmill or a solar panel just to be part of this great decentralization movement? I'm not so sure. I think we really need a policy framework that doesn't make things less efficient and more costly. That is for an industrial energy consumer enormously important, that we don't overdo it, that we don't over-engineer it. And that is why we support the market-driven aspect of the clean energy package, where we try to phase out support schemes and exaggerated schemes in member states. So we really have to go at it in a careful way, and so as not to lose also the consumers, because in the end, the consumer needs to pay for all this, and it will not be smart if in the end the bill is making people energy poor. Thank you.
Laura, would you like to answer this question, or any of you?
No, I'm not sure that anyone is suggesting to put solar on the roof of each houses. I think in Europe we've done already certain choices that probably were not the most rational in terms of cost-benefit analysis. But I think two things. One, as I said earlier, digitalization is not per se an objective. So we have other objectives, which are the decarbonization of the economy in a cost-effective way. And I think what digitalization can enable is, in fact, to tap on some of this cost efficiency that were not necessarily there before. So what we are seeing in households and the flexibility that an household can have, in fact, you don't need to build so much simply because you can tap on the flexibility that is there and the digital solution can unlock. So it's not about paying more, it's in fact using digital to pay less at the end of the day.
Mark?
Yeah, yes. Look, of course, we don't replace one way of working completely by another, but the decentralization is a fact, it's happening, and it's also a good thing because it allows for more renewables, which is what we're aiming for, because we're also in a hurry. If we want to combat climate change, we're in a hurry. It's not, let's go calm and check everything out and then decide in 20 years what the best idea is. And the decentralization and the fact that consumers get involved in putting solar panels on the roof, from that point of view, is a good thing because it diversifies, it pours into new sources of capital, new sources of investment, all of those things we like. And I would think from a SAFIC point of view, from a chemical industry point of view, that also means markets for a lot of new products. Of course, at the same time, we want to make sure that that happens in a way that keeps the energy prices affordable, competitive. So, as you already said, the clean energy package is a lot about how, we've kind of had a first wave of investments in renewables, heavily subsidized. That is not a long-term solution. So it needs to get more and more integrated into the system, into the normal way of working, which is luckily facilitated by the fact that all these renewables got so much cheaper. But let's not forget why they got so much cheaper. It's because there was a lot of public support for it to make it happen, creating scale, creating investments in innovation. And now we need to make sure that it is used efficiently in the system, and that digitalization is a huge facilitator and an enabler, but it means that we put the market framework right, and that we make sure that all these distributed assets, whether it's production or consumption, are used in a way that delivers the overall energy goals. So I think that's what we're trying to put in place. But the only thing I kind of disagree with you is that we have to go slow, or we have to be careful. There are some things where we are in a hurry, so we also need to make progress, and we need to hurry up.
Okay. Well, our time has come to an end. I am forced to finish here because otherwise I'm always attacked to be the late Italian, always asking for more flexibility and time. So here we finish. I would propose a round of applause for our speakers.